Hi, my name is Lincoln, and today I wanted to talk to you a little bit about my SSI fellowship plans. But before we get started, let me tell you a little bit about myself. So, I'm a lecturer in the School of Psychology at the University of Sussex. Here I mainly teach scientific computing and statistics. I have a passion for open source tools, tools for reproducible research, and I particularly like building tools for scientists and tools for doing statistical analyses. Outside of academia, I also have some industry experience, primarily in a startup building neuroscience-inspired AI. And I also run a blog over at Bits and Pieces, where I blog about programming and about statistics. At the moment, the blog is a little bit Rust heavy. So, as you're all aware, we're currently living through a climate crisis, and preventing catastrophic warming is going to involve changes in how we live. Now, most of these changes are going to have to come from governments or from large industries that are producing the vast amount of carbon pollution. But there are also changes that we can make as individuals and as a research community. So one thing that we can do is we can make changes to how we actually do research. Now, changes in how we do research and the climate impacts of research is something that's recently been recognized by the MRC with a recent funding call that has sought to fund grants looking at environmental sustainability in life sciences and medical research. But there are things that we can do on a smaller scale as research software engineers. Now, luckily, it's the case that a lot of the traditional concerns of software engineers also intersect with concerns that are good for the climate. So to take just one example, let's take something like computational efficiency. Research software engineers want to build software that is as computationally efficient as possible. This leads to reduced compute times, and all other things being equal, reduced compute times will lead to a reduction in energy consumption, which in turn is good for the climate. So to take another example, if we look at something like how we schedule HPC jobs, scheduling those jobs at times that can make better use of off-peak power is another way that we can reduce the climate impact of research software. Now, these are just two ways. Obviously, there are more ways. I don't know all the ways. I don't have all the answers. One of the aims of the fellowship is to actually bring people together and to work on ways that we can reduce the climate impacts of research software. But like I said, one way is looking at computational efficiency, and I think that's sort of the most straightforward way. And to see how this might work, I'll just go through a quick case study. So in this example, you can take an example of an R package, this R package called BFDA. It doesn't matter too much what it does, but basically it performs simulation-based statistical power analysis for Bayesian designs. Now, the code makes extensive use of nested for loops and fairly naive algorithms. And I came across this bit of code and I thought to myself, well, there's a way to improve this to get it to run more efficiently, reduce the compute times, and therefore reduce the climate impacts. So I set about rewriting it. My initial rewrite just rewrote it in R, trying to stick as close to the original language as possible. And when comparing my rewrite with the original ran 400% slower than the rewrite. So there was a big increase in how efficient this code was and a big decrease in the compute times. Now, because I wanted to see how far I could push this, I also decided to rewrite it in Rust, and rewriting in Rust then got us another order of magnitude in improvement in how fast this code can run. Because BFDA is an open source package, implementing these changes upstream is only a PR away, right? So as research software engineers, we can actually find code like this and we can improve it. This is one of the beauties of open source and one of the reasons why I love open source. Well, the fellowship will primarily be focused on running hackathons and workshops. Now, the hackathons can be run in conjunction with something like Hacktoberfest, and the idea will be to get a group of software engineers together, identify packages that we think can be improved, and actually submit climate improving PRs, ideally working together with maintainers in the context of something like Hacktoberfest. Also running workshops to see how we can actually improve our code and reduce the impacts of our scientific workflows. And this would be run in conjunction with a recently MRC funded research program looking at the climate impacts of neuroimaging workflows. And then lastly, outreach through the SSI blog to help inform and educate developers. Now, how can the SSI help? Well, primarily through funding for hackathons and workshops, and also prizes and swag for contributors and maintainers, because everyone loves swag, and that's how you get people involved. But I think the biggest thing that the SSI can do to help is the platform and the visibility that an SSI fellowship affords. The ability to blog on the SSI blog, the ability to have the SSI amplify these ideas, I think is the primary way it can help. And also the network to allow me to connect with other research software engineers to work on these ideas together and to see how we can actually improve our climate impacts of our work.